Hello and welcome to IEEE Soft Robotics podcast. In this podcast, we're going to interview researchers from both academia and industry about their work, thoughts, spectrum, and more beyond that. This is Marwa Edwini, and I hope you will find this podcast useful. If you would like to connect with us, simply send us, and we will be happy to hear from you. And here is my interview. Thanks.
Hello and welcome to IEEE Soft Robotics podcast. Hello, Professor Fumiya. Thanks so much for joining us for the third time in the podcast. And first of all, congratulations on the International Workshop on Embodied Intelligence. Such a great success. So yeah, and thank you for suggesting an idea. Such an honor to have you.
Yeah, thank you for third time interviewing me. I think this time I'm particularly happy because we're talking with you right after the Embodied Intelligence workshop, and this was I think it was a great success thanks to all the collaboration with the organization team as well as all the speakers contributed to the workshop as well as all the participants.
Wonderful, yeah. So maybe the first question people would like us to why started this idea of this international workshop on embodied intelligence? What drives you to do that?
Yeah, so I have been working on this embodied intelligence field for many years, actually 20 plus years now. And my original motivation studying robotics and especially bio-inspired robotics is because of the aspect of embodied intelligence, which I learned from my PhD advisor. In fact, our first embodied intelligence workshop was organized in 2003, so it's over 18 years ago now. And ever since, we didn't really came back to this topic of embodied intelligence explicitly, while we're focusing on different aspect of embodied intelligence, such as the Conference of Morphological Computation, Conference of Soft Robotics, and so on and so forth. But this time we come back to our origin of our interest in embodied intelligence, and we just want to go back, look back all this remain questions 18 years ago to see the whole field with the new technologies and a new set of eyes and the concepts and theories. And I think this was the really exciting opportunity to look back.
Yeah, that's great. So maybe for Sue, first time, maybe listening again, because you said last year about what is embodied intelligence, but through this year, is something changing because you have this expertise. What is actually embodied intelligence is? Maybe first time, just want to know.
So yes, embodied intelligence is not the well-defined concept for the last 18 years. And we actually deliberately not defining it because this is a kind of thing we should probably not define in the first place so that we can actually look at all the different aspects of the concept. So, but very roughly speaking, the embodied intelligence is the concept opposite to computational intelligence. As most of the people looking at artificial intelligence research these days, only focusing on information processing aspects, or in other words, the computational aspects of intelligence, which is basically information processing, right? And then, of course, this is a very important field for all the engineering and the scientific field, because if you look at our human intelligence, a lot of things are characterized by decision making or abstraction of concepts or learning of new way of processing information and the signal processing, or the world, the communication through languages and so on. So these are all information processing related aspects, whereas if we look at only information processing aspects, there are lots of important aspects in the context of physical entity of our body. So, and that's the kind of, place where we need to really address our interest in the context of embodied intelligence. So a lot of people talk about, just to represent how we characterize this field, whether brain is controlling our body or our brain is being controlled by our body, right? And we cannot really say which one is true. I think our body has, our intelligence is kind of both characteristics, and field of embodied intelligence specifically look at how our brain or control information processing is actually guided or structured by our physical entity of embodiment, and that's the idea of this field.
Wonderful. I think quick question here about people ask about the consciousness in that case, and do you think it comes from the brain or the body? Because we see some creature, they don't have a brain and they have this kind of consciousness, and how we can prove which one it's come from, and if we wanted to design the machine, should we need consciousness in that case?
So yeah, the question of consciousness is one of the ultimate questions, right, of the human level intelligence. If we want to understand it, we probably need to understand consciousness as well. But at the same time, consciousness is something we cannot really easily define. There are many different ways we can define it, just like the concept of intelligence and the concept of life itself. What do we mean by living and non-living organism, and all that kind of things somehow come together. We know what it means as soon as we see this conscious, living, intelligent agent, but it's very difficult to define it until we see it. And so that's why I try not to define this field or these concepts, but because that's something we should probably it's difficult to define, so that's how I feel.
Yeah. So I think one of the questions when we design the robots, how should the brain and the body evolve when it comes to open-ended environment? Because people speak that how you feel about soft robotics, for example, when we design the brain and the body at open-ended environment, we're assuming that how should maybe grow each other or individually, and if there's damages happening, that's one of scenario, the redundancy, how they can adapt to this kind of new adaptation, like damages in the brain or damages the body. So how do you imagine something like that, the design process, when it comes to applying this concept?
Yeah, well, if you ask this question, we ultimately go back to the question of how evolutionary process actually works in nature, right? And in fact, we can look at evolution from all different directions, from genetic level to behavioral level or some conceptual level. And if you look at the Charles Darwin, his idea of natural selection comes from diversity and the heredity, right? How you can inherit the previously developed characteristics, but this is true to a certain extent. But if we start applying this concept into real design process of robots or some artificial systems, then that's not necessarily easy to implement. There are lots of missing aspects of a Darwinian way of looking at evolution, and so that's one aspect we need to really discuss in the context of embodied intelligence, because some people talk about in the workshop, for example, talking about what's the role of environment, the system environment interactions, and what kind of environment is necessary to have the evolution happens in the right direction. Or another thing is the imitation and the social aspect of it, how human interaction or the child-parent interaction involved in the design and evolution process of organisms, and all these things are kind of left behind when we talk about the Darwinian way of looking at the evolution today. But this is coming back to the discussions by thinking about embodied intelligence. I think that's the really interesting aspects of this community to discuss what the intelligence from the embodiment point of view.
Yeah. And I think also one of the question about how we can evolve the design of the brain of the body. For example, when we see in nature, we can't evolve everything that could affect our fitnesses. That's why we don't have like visors. That's kind of question why we have a certain design. So when it comes to design the brain and the body, how do you figure out what kind of evolution you want to reach? For example, it is optimal or adaptable. What kind of solution, and when it comes to soft robots, for example, you want to reach?
Yes, this is all difficult questions you're asking me today. For example, we don't know what's the fitness function, right? Usually, if you look at the genetic algorithm or evolutionary algorithm, we set the desired fitness value, fitness function, how we want to see the agents to be evolved in the process, and that's set criteria by human designers. But the nature doesn't have such a clearly defined the fitness function and so on, and we don't even know what's the driving force of evolutionary dynamics, and that's exactly what we discussed in the Embodied Intelligence workshop, in the sense that there is some sort of intrinsic motivation in the evolutionary process. At least it looks as if there is some intrinsic motivation driving the whole process, and that's something we don't know how and where it comes from, and how we can study such a really exciting but difficult problems that we need to define. And that's where we are at the moment, I think.
Yeah. So maybe we can go for a workshop, because you have this more than 20-year expertise, and this workshop's first time to be focused on embodied intelligence. And one of the questions we have, I think, Rebecca, with asking whether morphological computation is sort of embodied intelligence or not. If you can tell us what something maybe before the workshop, something was maybe confusing for you and still more confusing. I don't know what kind of thoughts after this all speeches we have, but something still maybe still confusing or hard to understand, you can share with us when it comes to embodied intelligence.
So when we discussed the morphological computation first time is something around 2006 or 2007, which was actually a lot after when we are talking about embodied intelligence. So from my point of view, morphological computation is a kind of small subset of embodied intelligence, in the sense that we want to understand what morphology is, and we want to understand what the computation is in the context of embodied intelligence research. So so that from that point of view, it's a very different thing. So morphological computation is more specifically looking at what is computation process in the first place, right? In embodied agents, all the computation process from conventional Turing computations to whatever quantum or biological, that DNA computing, we always have some sort of physical dynamics behind it, and then the computational process somehow comes out of this, right? So that's also fine, but we just need to understand what the computation in the context of a physical embodiment setup. And then the morphology part is again, we specifically look at this mechanical properties or geometrical properties of embodiment. But we don't really talk about other types of embodied interactions, and social interaction is not included in morphological computation, for example. So yeah, embodied intelligence is actually much broader concept compared to morphological computation. But there are lots of common interest, and there are real the benefit to both community of the studies. So I think that's how I understand the whole two different concepts.
Wonderful, yeah. So maybe I would like to ask again, because people ask a question: should we design soft robots that have level of consciousness for example, when we have Professor Carl speaking about the free energy principle, and there's a lot of controversy behind this theory, that do you think we need this kind of conscious soft robot? Is it necessary, or you don't think we don't have to have this kind of feature when it comes to design soft robots?
Well, I think the idea of consciousness study is a very deep one, and it's connected to the question about what is life, or what is human, what's the human intelligence, and so on. And if we want to understand human level intelligence, this question about consciousness you cannot avoid, because these are really two probably the same problem, or the flip side of the same thing. And we still don't know what consciousness is and how we can study this, but and probably don't have answer, no matter what we do. But still, I think this is the question we need to tackle if we want to understand what the human level intelligence is, or even, the lower level, the other animals' intelligence. We just need to understand this question about the consciousness. And I think one way to understand the consciousness is certainly, Carl Friston really nicely capture in his theoretical approach of free energy principles, and that was very well thought principle to deeper understanding of our consciousness. And but I'm sure there are many different ways to look at it, and that's what we all trying to figure out.
Yeah, that's a good point. Yeah. So maybe for a student, maybe interested to dig deeper in that case, if you have this kind of like perspective, what's something you think still may be missing after this long years, and we think after the workshop we have give much attention or focus on certain direction? What that direction you think we have to go for after this meeting, this workshop?
Yeah, that's a very good question. So when we are first organizing this workshop, we struggle who to invite and who not to invite, and this is the most challenging aspect of this, because we need to include all different aspects. So for example, this time we had a lot of researchers from neuroscience, brain science type of researchers, and these are often not very included, not very related to, for example, research of morphological computation or research of the soft robotics, because it's just too far away, right? But no, now I think we, in this particular workshop, we try to have an integrative view, including brain science and the consciousness research, and this. So the philosophy of intelligence research is another aspect. So that's the highlight this time. But obviously, on the other end, we have to. We could not include, for example, more biologists or more material scientists. They are rather minority in this workshop, but they should be also there if we really want to build up the whole theories and the concept of embodied intelligence established. So all these different fields are important. Yes, and then another aspect of physics, right? The physicists, we have a few physicists this time in conference, but they have also their own views of how they want to understand embodied intelligence. And probably, we're going to continue with this organization of embodied intelligence workshop in the future, and trying to focus on different aspects of this field by inviting speakers from different backgrounds.
Yeah, that's a good point. Yeah. So maybe a question about what could be forms of embodied intelligence, because it seems there's, as you say, there's no generic definition. But when it comes to the material, for example, in soft robotics, do you think we have to design a system that have the sense and actuation intrinsic feature? Or what kind of forms do you think, we can call it embodied intelligence when it comes to design soft robots, for example, in the case? What are the forms do you think could be called embodied intelligence?
Yes, I think that's a really fundamental question. Like we don't really have a shared view on this, but one of the common interests after listening to all the speakers in the workshop is that there's a key aspects in terms of a complexity of the system. Like if you look at the biological organism, they have incredible complexity in mechanical settings, right? They, a number of actuators, number of sensors, number of neurons, and a number of cells in one organism. And even if you look at one single cell organism, there's so many different aspects of complexity in terms of diversity of molecules, different kind of molecules, and different types of interaction with the environment. So all this, the complex nature of a biological organism has something to do with the consciousness, with the life, with the intelligence, and so on. So one of the things I was, I took note during the workshop is that the complexity is the starting point, but also the interesting thing is how simple mechanism come out of this complex organism. And this is the kind of one of the biggest questions, on the one hand, how we can make a really complex organism, lots of sensors, lots of motors, lots of computation in one, a single entity, while it behaves in a purposeful way, right? So that's the beauty of this embodied intelligence research. I think this is the kind of things that lots of people in this community are looking for.
Yeah, that's a good point. I'm curious to see what kind of tools do you think, maybe when it comes, for example, some people will speak about simulation to reality and how we have high fidelity simulation when we want to simulate this robot at open-ended environment. What kind of tools do you think, maybe modeling, I don't know, what series do we need? What kind of tools missing, or maybe have to enhance it to achieve embodied intelligence?
Yes, that's a good question. If you go down to the actual nitty-gritty of how to build robots, embodied intelligent robot, we need to go down to the material level, like a soft robotics material level integration of complex systems, right? We need to integrate sensor and motor in the material level so that we can make it sufficiently complex. And but on the other hand, we also want to do the simulation of such a complex things. And I think we have a good progress in how to do the complex simulation in the physics engine and so on. But still, this is all the work in progress, I would say. If we want to simulate something like the human body complexity, right? But after all this component technologies, I think one of the really the most missing tool is actually theoretical tools. Like we don't know how to measure the complexity of the body or complexity of the interactions and so on. So so this part is still missing components that we need in the embodied intelligence research. So I think that's probably one of the big challenge.
Mm-hmm. That's a really good point as well. Yeah. So since we're close to the end, I have a few questions. The first one, when it comes to for research in embodied intelligence, since you're doing that since 20 years, what could something still aspiration for you when it comes to achieving embodied intelligence? Something thoughts do you have, or crazy ideas when you think about it?
Yes. So that's a very good question. One of the reasons I call my research lab the bio-inspired robotics is because I don't want to forget the complexity of biology, like how far we are with the robotics technology. So we are, doing robotics, but and sometimes we're, arrogant about what we can do with robots, right? But what biology can do is actually completely in different dimension, completely different scale, and that's always the driving force of our research. And no matter how hard we work, the complexity of robots is not at the level of biology. And even with compared to the simplest biological organism, our robots are never there yet. So that's the kind of driving force of our research, and how we can, ever catch up with biological systems. And I don't know how long it's going to take, 50 years, 100 years, or maybe, a couple of 100 years. And that's where I think that's the real challenge from our point of view. Yeah, we're a long way forward. So that's where we are.
Great, yeah. So maybe I'm curious about the recommendation from this workshop. So I think you have a lot of something I think to do behind this workshop. So what could be a recommendation, or maybe something you can share, like main points about this workshop, like to take in our mind and stick to answers questions, if any recommendations you have.
Yes, absolutely. I think one of the goals of this workshop was trying to get as many people as possible with a diverse background. So we try to include, we actually have 120 talks in 2.5 days, right? It's kind of crazy, the dense experience of all of the students, and even for the academics. Like we usually don't have this packed schedules, but I think this was really, really important, because we need to know the perspective from other background, other people, and what they think about embodied intelligence. And all of these speakers were selected and highly selected, the top researchers around the world. And I'm just trying to see what we can do together. And it's very important to be connected to the people who thought of this problem a long time with a significant depth. And still we haven't solved these problems, right? So I think it's very important to be connected to the experts of the field, and we just need to have a kind of the mindset to work together for such a exciting and profound research challenge.
Yeah, first of all, thank you for saying that. And I don't know if you have advice for student, maybe, or something you would like to advise, from this workshop you can give to student or researchers.
So there are lots of challenges in front of us, but when it comes to come down to the daily life, you need to solve this problem and that problem in a much smaller scale, right? So it's really difficult to think of today and tomorrow problem while 100-year-long research program, right? But I think it's very important to have this mindset to think both short-term and very long-term projects, and that's not easy skills to have, but that's the most exciting aspects of being a scientist, being a researcher. So even if you think of today's problem doesn't look like groundbreaking, world-changing, but that's always leading to the longer time scale problems, and we should not really lose this the mentality to do our daily research projects.
Thank you for sharing this mentality. I think that we need that. I don't know if you have any final words, since you initiated this series already. So I don't know if you have any final words you'd like to say in this series about intelligence. Any final words you'd like to say?
Yes, I think this was a really good. Well, first of all, I would like to thank everyone involved in this embodied intelligence workshop in the last 3 days. This was really collaborative effort, and we could not make it if we don't have all this greatest mind around the world. So that's the first thing I want to say. And the next thing is, we're always open to whoever who is interested in embodied intelligence. And, I think this field has a kind of room for many different backgrounds, not only robotics and brain science and material science, but it's open to biology, philosophy, social scientists, psychologists, computer scientists, mathematicians, right? It's basically anyone can join this this field. So we would like everyone to encourage to at least look at it and think about how we can contribute to this, and then we can actually try to make a collaborative and a fruitful community altogether.
Thanks so much, Professor Fumiya. I think it was a pleasure to see you, and thank you once again for stitching our community through this event for first time in our field. So thank you, such a pleasure to have you. Thank you.
All right, thank you very much, Marwa. I think this was also enjoyable.